Welcome everyone to the last video of the DP-900 Cert Prep course. Um, After this video, the only thing that we will be focusing on is a review for the actual DP-900 exam. So within these slides, we're just going to go over the last few concepts that you need in order to successfully complete your DP-900 exam. I have a little bit of a review in these first couple of slides. However, instead of just asking you all to think about the answer, pause, and whatever, I'm actually going to go over these questions with you all during the actual class. So feel free to look through these questions, think about them if you'd like, but we'll be talking about these in person. And with that, let's jump right into OLAP stores. Keep in mind, OLAP stands for Online Analytical Processes. These are your non-relational databases, the ones that you use for analytics, non-transactional processes. So we've talked about NoSQL solutions. We've talked about relational databases. We've talked about different file stores and blob containers, but we haven't really spoken about specific concepts in OLAP. And this is essentially the last concept that we really need to get down. So OLAP solutions, just as a reminder, don't focus at all on line of business operations, such as keeping track of events or customers. Instead, the only thing that we are worried about is read operations, which is analytics, right? Excuse me. If you're not interested in creating a database to and in fact, you don't really need to create a database to perform analytical operations. OLAP is your best bet instead. Now, some common terminology that we should get acquainted with in terms of OLAP stores include data warehouses, data lakes, which we actually already talked about in the last lecture, and something called data lakehouses, which is a little bit of a combination of data warehouses and data lakes. So first up, what is a data warehouse? The funny thing is a data warehouse is actually just a relational database, but it's a relational database that's structured in a highly specialized way that's optimized for analytical reads. So just keep that in mind. When people talk about data warehouses, they're really not talking about any specific unique tool. Really, the only thing that they're discussing is a relational database that you've arranged in such a way that you can perform analytics on it easily. And really, there should be no reason why you can't do this, right? Think about the databases that you've used in the past. You can arrange that data in any way you see fit. We tend to recommend to normalize the data if you're looking to perform OLTP processes. However, if you need to do analytics, you're going to arrange your data in what we call a star schema. Now, what is a star schema? A star schema is a highly denormalized structure where instead of prioritizing data redundancy and integrity, you're instead prioritizing the ability to pull different types of information on one specific metric. Now, the way star schemas are arranged is in the center, we have something called a fact entity. And this essentially, or rather a fact table. And this fact table essentially keeps track of some sort of discrete metric, such as the sale that was performed. And then to associate different dimensions with this fact, we have other tables such as dates, customers, product, and store, which we can then easily associate with the fact table in order to pull some sort of specific analytical, basically in order to perform some sort of analysis on the specific fact. Let's say that you want to figure out how many sales were performed from 2017 to 2019. Well, you're probably going to have to associate the sales fact with the date dimension. Let's not get lost in the weeds, however, and let's just focus in on the terminology that we're playing with here. This table in the center, which records the specific metric, is called a fact, and the tables that are associated with this fact are called dimensions. And they usually are some sort of, well, for lack of a better word, dimension that we use to associate or rather to make sense of our fact table. So that's really the key terms that you need to get down here. In the center is fact, and then connected to this table are dimensions. Now, and this is exactly what I said before. One thing to also note is that our fact table, it has many one-to-many relationships with different dimensions. And these dimensions basically represent entities by which the data can be aggregated on. We could make our star schema a little bit more complex by adding normalization or by even adding more associations in our dimensions. And this gives us different other types of star schemas called snowflake schemas or a galaxy schema. You really don't have to worry about the details of this. The only thing you need to acknowledge is that these things exist, and you need to understand that they are necessary for creating what we call data warehouses. In fact, I would probably argue that only the snowflake schema and the star, you should only be familiar with the snowflake and star schema for the DP-900 exam. And so just to reiterate, the star schema is a simple arrangement where you have a fact table and a bunch of dimensions, whereas the snowflake schema is the star schema again, except this time you have a bit more complexity within your dimensions. Notice how the date dimension is actually broken down further into other dimensions, hence the normalization. Now, to implement a data warehouse, just like I said earlier, you don't need any specific tool. Really, you can implement this in Azure SQL, Azure Cosmos, or Azure databases for open source relational databases, such as Postgres, MySQL, or MariaDB. Once again, these are just basic relational OLTP databases. So we talked about data lakes last week, but let's just talk about them once more. Data lakes are a form of OLAP data stores. You keep track of whatever you'd like within a data lake. Could be an image, video, any other blob file. The only thing is that, and in fact, actually, it is a blob container, but you just enable hierarchical namespaces. This allows us to add a little bit more structure to our data store. And in addition, it also scales up our analytical capabilities. Let's actually get down deeper into this. So when you create a data lake, what you're also able to do is run these specialized softwares or tools called MapReduce. One form of them is called Hadoop, which basically allows you to do super quick analysis and calculations on your data using this really complex method. Maybe we'll talk about the research paper in next week's class, but the only thing that you really have to keep in mind is that having a data lake allows you to perform faster analysis, essentially. And just to add more context, if you only have a couple megabytes or even a couple gigabytes of data, maybe a data lake is not really necessary. Data lakes are really designed for large data, like we're talking about terabytes of data, many different types of data files across many different folders. So if you're going small scale, blob containers are probably good enough for your purposes. All right, and just like we mentioned before, to create a data lake, you need to first create an Azure blob storage, enable hierarchical namespaces, and then if you want to perform analysis on your data lakes, you could utilize something called Azure HD Insight, which comes with Apache Hadoop and Apache Spark. All right. Next up, everyone, we have some hybrid approaches. Not really too important to know, but I guess it is good to just acknowledge its existence. Occasionally, what you could do, or rather, not even occasionally, what you could possibly do is add a relational storage layer to your data lake, which abstracts the underlying files and basically treats them like tables that you can interact with on SQL. If you remember the capstone project, at some point we actually used an AWS service, essentially AWS Glue, and I think it was AWS Athena, which allowed us to treat our CSV files as SQL tables. This is essentially the same exact process. In Azure, or in general cloud terminology, this is known as a data lakehouse. It's basically an attempt to combine the ACID properties of a relational database on the flexibility of a data lake. Now, to implement this, we would have to create something called Azure Synapse Analytics and also create something called a Delta Lake. Now, I know I'm like throwing a lot of different terminology at you and new concepts. One thing to note is to always rely on a first principles approach. Think about what you're trying to accomplish and consider, after learning about these different tools, how they will help you accomplish it. If you find out that really all you need is a relational database, then it's best to really go simple. All right. Yeah, so once again, just to reiterate all these concepts, a data warehouse is a relational database in which a schema is optimized for analytical reads, and this includes star schemas and snowflake schemas. A data lake is a file store on a distributed system. A data lakehouse is a file store on a distributed system abstracted by a relational schema. All right, and here's a little bit of a review question. This is an actual Azure question. Take a look at this thing right here. What kind of data model is this? Is it a transactional model, a star schema, or a snowflake schema? Take a second. All right, it is a star schema. Keep this in mind. If you see a fact with simple dimensions that don't get broken down any further, you're looking at a star schema. Now, what about customer? Is this a fact, a dimension, or a bridge? Think about that for a second. It is, in fact, a dimension. Remember, in the middle are your fact tables, and on your margins are your dimensions. All right. Let's see here. We actually didn't get into ETL just yet, so I'm going to skip through this. Let's talk about pipelines. Let's actually get into ETL. So we talked a little bit about pipelines during Capstone, and we also briefly talked about pipelines earlier in this course. Let's actually, once again, formalize some terminology. First up, data ingestion and processing. What does it look like to ingest data into a cloud system? Excuse me, or really into any system. So as you've seen from your Capstone projects, you're going to be pulling data from many different sources. If you're lucky, you'll have an API that your company pays for, or maybe some CSV files that you have ready. If you're unlucky, you'll have to do web scraping. Now, whatever you choose or however you choose to get your data, you're going to extract this data into a data lake or maybe a data warehouse, and you're going to then feed it through either an ETL, extract, transform, load, or an ELT, extract, load, transform pipeline. Now, I know this is quite boring, and I'm really just like flip-flopping two terms, ETL, ELT. What's the difference? Yeah, once again, everyone, keep in mind, this information is bounded by its utility. So if you find that it's useful for your purposes, awesome. If it's not useful for what you're designing, then honestly, why should we care? Anyways, let's pretend to care about it for a little bit. ETL pipelines. This is when you pull data, you transform it, and then clean, and then you load it back into some sort of OLAP solution, such as a data warehouse. That's, once again, extract, transform, load. You're extracting the data, you're web scraping it, you're performing some sort of transformations to it, and then finally you're loading it back into whatever database or file store you're using. Pretty simple. In fact, that's actually what you all designed for your Capstone project. Then you have your extract, load, transform pipeline, and the only difference between this is that instead of eventually loading your data into some sort of specialized system, what you're actually doing is you're first extracting your data from whatever resource, you're loading it into the analytical database, and then you're applying transformations while it's inside of the analytical database. This system right here actually relies on things like Apache Spark and Apache Hadoop, because then what we can actually do is rely on those specialized cloud systems to perform some sort of transformation on a huge set of data. Really, if you have a small amount of data, and what small means is really subjective, let's say 100 gigabytes. Well, even then, that's actually pretty large. let's say 20 gigabytes. I'm just speaking from experience. Yeah, let's say you have a small data set that's less than 20 gigabytes. Extract transform load, probably good enough. You probably won't be wasting too much compute creating ETL pipelines. However, on the other hand, if you have a large data set, and I'm just going to do, well, let's do 100 gigabytes. Anything between 100 and 20 is in the gray zone. Anyways, if you have a large data set that's 100 gigabytes, then maybe what you want to do instead is use a extract load transform, where you're going to load this data into some sort of Azure system that has Apache Spark. You're going to perform, or you're going to write some sort of script that essentially allows you to take advantage of the Spark system, and you're going to perform super fast and super efficient transformations without having to worry whether or not your script will be able to successfully perform the transformations. Keep this in mind, everyone. We really haven't had the opportunity to work with huge data like this. I hope one day I'll be able to bring this to the fellowship. But if you are working with gigantic sets of data, extract load transform is probably your best bet. Okay, now let's actually define two more terms, batch processing and stream processing. These things are pretty cool. Batch processing is basically processing data at rest. Everything that we've done is batch processing so far. Basically, you have some data that's sitting in some sort of Google Drive or a folder, and you're just performing processing to it. You're using pandas or Spark or whatever. Oftentimes, we can use parallel jobs to basically perform parallel executions on our data set in order to speed up our process. This is great for large, flat, and complex data transformations, which is essentially what we've been doing throughout this entire fellowship. However, there's also something called the real-time or stream processing, or also online processing. And this is when streams of data are captured in real time. And this is really fascinating. Think about things like Fitbit or your Apple Watch, or I don't know, any sort of system that tracks data live. This right here is when data is captured in real time and processed with minimal latency. You're not processing data at rest. You're not letting your system run for like 2 hours or an entire day to process a data file. No, instead, you're actually getting one row of data at a time, and you're immediately doing something to it. This is great for processing unstructured data with milliseconds of latency. And this is like the real cool stuff. Maybe even financial data falls into this, or high frequency trading algorithms. They receive information within milliseconds. They perform some sort of operation, or they transform that data, somehow in order to gain some sort of insight or leverage on the market. All right, now, in order to create these ETL and ELT pipelines, we have the option of either using Databricks, Data Factory, or Synapse Analytics. In order to construct these pipelines, we use something called an activity, which is essentially a data flow that incrementally manipulates the data until we receive an output data set. And we'll talk about this a little bit more during class as well. Maybe we'll be able to open up the Azure service. Furthermore, pipelines also use something called a linked service to load and process data. So obviously, you're going to be pulling the data from somewhere, right? Whether it's a Python script or an existing relational database, you're going to have to link that service in order to your pipeline, whether it's Databricks, once again, Data Factory, or Synapse, in order to generate your ETL pipeline. All right, yeah, let's see here. Oh yeah, and this is Apache Hadoop and Apache Tinkerpop. These are just basically, well, okay, Apache Tinkerpop is a GraphQL database. I'm not too sure where I was going here. I think I just like enjoy the logos or something along those lines. Anyways, that right there were OLAP stores, and we'll definitely come back to that again because that was definitely a very dense topic. Next up, let's talk about OLAP models. And let's summarize OLAP stores. Essentially, after we've ingested the data, then we've stored the data in some sort of read-optimized relational database or shared file structure, aka warehouses or data lakes. Now, after we've stored the data, we next need to model the data. And this is where it gets a little bit more complex, and this is where we get into some advanced analytics concepts, specifically something called the cube. Here, we basically pre-aggregate the data to make it easier to produce reports, dashboards, and interactive visualizations. This allows us to capture relationships between values and dimensional entities in order to support something called drill up and drill down analyses. Really, this is a very, very abstract way to talk about the cube. Essentially, what you're doing is you're calculating a whole bunch of pre-aggregates, so you don't have to actually calculate these pre-aggregates live. Like maybe you were calculating the sum for every customer between some date range 1, date range 2. And yeah, we pre-calculate this, we load this into what we call the cube, and then what we're able to do next is quickly get information on some sort of customer by drilling down or either drilling up to get information on how our entire customer base is doing. Pardon me. Anyways, and lastly, everyone, we have something called analyses. This right here is really the easiest part of the DP-900 course, in my opinion. Really, this just has to do with creating data dashboards and making good visualizations. And this has to do with the realm of business intelligence. We create visualizations in order to show trends, make comparisons, show how our KPIs are performing for the business or for some other business that perhaps we're even consulting. Here's an example of a data analytics question from the DP-900 exam. As you can see, they really aren't going to ask you anything too hard. A visualization that illustrates a university's current student enrollment per department is an example of what kind of analytics? Cognitive, descriptive, predictive, or prescriptive? Think about this for a second. All right, so let's break this down. You are illustrating a university's current student enrollment per department. What is that? Are you predicting? No, you're not talking about future enrollment. Are you prescribing? Are you telling them what they should be doing? Not really. Cognitive? No, right? Cognitive analytics, I would probably have to honestly Google that, but I think it has to do with, I don't know, perception or something. Honestly, we're quite simply just going to go with descriptive, and that is indeed the correct answer. This right here is what we call descriptive analytics. Descriptive analytics, everyone, if you're just calculating averages or calculating typicality of a data set, that's descriptive analytics. You are describing the status of something. Yeah, in fact, most analytics that we've done, 90% of analytics, that's terrible statistic habits. I don't know if that's truly 90%, but most of the analytics that we've done throughout this fellowship has been descriptive. All right, let's talk about ETL, or rather ELT pipelines. So extract, which one do you think goes in the extract category? A data analysis tool, a CRM system, or a data warehouse? This one's a little bit tricky, so I think I'm just going to give you the answer. That's going to be the CRM system. CRM, I think this has to do with like content, some sort of content system. Basically, where are we getting the data from? This was like through a process of elimination. Well, let's see here. Yeah, I believe CRM is going to be the correct option. Next up, where do we load the data? To be loaded in a data warehouse or in a data analysis tool? The answer is going to be we load our data in a data warehouse. And finally, where do we transform our data? That's going to be inside of a data analysis tool. All right, let's go ahead and skip through this. We'll go over through this in class. And then we have the practice exam. And honestly, we already talked about the practice exam, so I'm not going to go over this too much. Just go ahead and take a look at the DP-900 website that I posted. Try to get that done by next Tuesday, which is September, what is that? September 2nd, I believe, or September 3rd. Yeah, and from there, we will continue our conversation. Ignore this date. This is from last year. All right, everyone. Thank you all so much for watching through the entire series. And yeah, we'll keep studying. Good luck.